Hi, and welcome to day 8 of polynomials. Today we will be talking about radicals and their conjugates. So which of these statements are true for all a and b greater than 0? And explain your conjecture. So is 2 times the quantity a plus b equal to 2a plus 2b? The answer is yes, this is true. And that is because of the distributed property. This is the distributed property. Okay? And then for part 2, is a plus b divided by 2 equal to a over 2 plus b over 2? The answer there is yes, because we can do our regular division, and we can divide a by 2, and we can divide b by 2, and you can have 2 separate fractions. So this is true, because this is just division. So number 3. Is the square root of a plus b equal to the square root of a plus the square root of b? Well, this is false. And this is a mistake that a lot of students make. And we need to be careful with this. And I'll give you an example of why it doesn't work. And as soon as I can show you an example of why something doesn't work, then we know it doesn't work. So if a is 16 and b is 9, inside I would do my order of operations and I would add 16 plus 9 and I would get 25. And here I would take my square root, I'd get 4 plus 3. So the square root of 25 is 5, and the square root of, or 4 plus 3 is 7. They are not equal, therefore that is false. So anytime I can show you an example where it doesn't work, then it's automatically not true. So yesterday in class, I think I may have asked you, why do we even have to simplify radicals? What is the point of simplifying a radical? Well, if you can't simplify a radical, then you cannot add or subtract them. Because right now I have the square root of 50 minus the square root of 18 plus the square root of 8 in simplest radical form and combine like terms. I cannot add and subtract if my radicals aren't alike. It's like adding x's and y's together. If I don't have 2 x's or 2 y's, I cannot combine them. So I need to break down, simplify my radicals first. So this is 25 times 2, and that gives me 5 radicals. 2 for 50 minus 18 is 9 times 2, so that is radical, or 3 radical 2. And then 8 is 4 times 2, which is going to be 2 radical 2. So now I can add these, 5 radical 2 plus minus 3 radical 2 plus 2 radical 2. That is exactly the same as saying 5x minus 3x plus 2x. And when I add those together, 5 minus 3 is 2x. 2x plus 2x is 4x. But in the problem up above, where we have the radical 2's in place of the x's, I just add and subtract the coefficients. So 5 minus 3 is 2 plus 2 is 4. And we keep our radical 2 just like we keep the x. All right. Then I get really excited here. Now you try. But we're going to do these together. So the first thing I need to do is simplify. When I have a fraction underneath the radical, I simplify the numerator and I simplify the denominator. So I have the square root of 1 over the square root of 4 plus the square root of 9 over the square root of 4 minus the square root of 45. So if I have square root of 1, I take that, I will get 1. The square root of 4, I get 2. Plus the square root of 9 is 3 over the square root of 4 is 2, minus 45 breaks down to 9 times 5, so it is 3 radical 5. So I'm going to combine my like terms. My first 2 terms are like because they're both a half and 3 halves, and when I add 1 half plus 3 halves, I get 4 halves, and 4 halves is really just 2. And then I can't combine it with the 3 radical 5, so I just write 2 minus 3 radical 5. For number 2, I'm going to multiply. And when I multiply radicals, I multiply outsides, and I multiply insides, and then I simplify. So I have 3 steps. So I'm going to multiply my outsides. Those are both 1, so I don't have to worry about that. And then I multiply my insides. Radical 2 times radical 3 is radical 6. Minus radical 2 times radical 2 is radical 4. Radical 6 cannot be simplified, so it's just radical 6. Radical 4 can be simplified, so it's minus 2. For number 3, we have a little problem here. It's breaks down to radical 3 over radical 8. Well, in math, we don't like to keep a radical in the denominator. And 8 is not a perfect square. However, if I were to multiply 8 by a number, I could turn it into a perfect square. If I were to multiply 8 by 2, it would become 16. So I'm just going to multiply 8 times 2, and I'm going to get 16. But if I multiply 8 times 2, I also have to multiply the 3 times 2, so I get radical 6. What I'm doing is I'm changing the way it looks, but it's still equivalent because I just multiplied by the same number. So it's really like multiplying by 1 in disguise is what I call that, or incognito. So radical 6 cannot be simplified, but radical 16 can become 4. And I cannot simplify that anymore because 6 is under the radical and the 4 is not. All right, for number 4, I have a cube root. 32 is not a perfect cube, but my next closest perfect cube to 32 is 64. So again, if I double that, so it's a cube root of 5 times 2 over the cube root of 32 times 2, I will have the cube root of 10 over the cube root of 64. The cube root of 10 cannot be simplified. However, the cube root of 64 can become a 4. Number 5 is just like we were doing in class today. So this is the cube root of 16 times x to the 5th. Well, 8 times 2, because 8 is the smallest or the largest perfect square that divides into 16. The cube root of 8 is 2, and then I still have my 2 left over. And x to the 5th, remember 3 goes into 5. How many times? That is 2. And then how many do I have left over? Well, that is also 2. All right, let's flip to the next page. Multiply and combine like terms and explain what you notice about the 2 different results. All right, so here, when I multiply, you can do this with the box method if it's easier for you to do that, and I don't care. For some people, this is easier. Radical 3 times radical 3 is radical 9. Radical 2 times radical 3 is radical 6. Radical 3 times radical 2 is radical 6. Radical 2 times radical 2 is radical 4. And when I go to simplify that, radical 9 is just 3. And 2 radical 6s here on the diagonal, so it's plus 2 radical 6. And the square root of 4 is just 2. I can add 2 plus 3 and get 5, but I cannot combine it to the 2 radical 6. Now, I'm going to do the same thing here, except there's one difference in the problem. This is a negative radical 2 on the bottom. So radical 3 times radical 3 is radical 9. Radical 2 times 3 is radical 6. Negative radical 2 times 3 is negative radical 6. And negative radical 2 times radical 2 is negative radical 4. Now I'm simplifying. Radical 3 is just, or sorry, radical 9 is just 3. Here I have a positive and negative radical 6, so they cancel each other out. And then I have minus, and the square root of 4 is 2. So my answer is just 1. Now, this answer here is just a 1. This answer here is 5 plus 2 radical 6. My first answer has radicals. It's irrational numbers left in the problem. My second answer does not have any radicals left over in the answer. And the reason is because of that negative sign. These two terms are what we call conjugates. Okay? And conjugates have the same numbers, except one is positive and one is negative. You may have heard of this when you were factoring, and we called it, some teachers called it the good twin and the bad twin. They look exactly alike, except one is positive, one is negative. That's what these are. So find the product of the conjugate radicals. And you're going to see this word, and it's important to know what a conjugate is, because a conjugate can actually help you get out of a lot of trouble later on. When I multiply, let's try these conjugates here. This is radical 5, radical 3, radical 5, negative radical 3. Radical 5 times radical 5 is radical 25, which is 5. Radical 3 times radical 5 is radical 15. Radical 5 times negative radical 3 is negative radical 15. And then radical 3 times negative radical 3 is negative radical 9, which is a negative 3. So again, on the diagonals, those cancel out. So I just really have 5 minus 3, which is 2. Let's do the same thing with my next pair of conjugates. So I have 7 radical 2, 7 minus radical 2. 7 times 7 is 49. I'm not taking any square roots here because there is no radical. 7 times radical 2 is 7 radical 2. Negative radical 2 times 7 is negative 7 radical 2, negative 7. And then radical 2 times negative radical 2 is negative 2. So my negative radical 7 and my positive radical 7 are going to cancel each other out. So I really have 49 minus 2, which is 47. The last one. And I have radical 5 and 2, radical 5 and negative 2. Radical 5 times radical 5 is still radical 25, and that's 5. 2 times radical 5 is 2 radical 5. Negative 2 times radical 5 is negative 2 radical 5. And then 2 times negative 2 is negative 4. Again, those cancel out because one's positive, one's negative. And I have 5 minus 4, which is 1. This is the case every single time you multiply conjugates. Your diagonals are always going to cancel out. So in essence, you don't have to do that middle multiplication. You can just fill in this box and this box, or this box and this box, and then subtract the two numbers. It's always going to be the first number squared minus the last number squared. If you get a radical in your answer when you're multiplying conjugates, you have made a mistake and you need to try again. All right, next page. Last example. Write radical 3 over 5 minus 2 radical 3 in simplest radical form. Okay, so when we have this ugliness in the denominator, we have to get rid of it. And I need to get rid of my radicals. I just can't keep radicals in the denominator. I just can't keep radicals there. They're just not allowed. So what we were just doing is multiplying everything by the conjugate, and that was getting rid of my radicals. Well, that's what we do to get rid of radicals. We multiply the top and the bottom by the conjugate of the denominator. So the numerator, I'm going to have 5 plus 2 radical 3 over 5 plus 2 radical 3. 5 plus 2 radical 3 over 5 plus 2 radical 3 is 1. But it's just what I call 1 in disguise. It's incognito. So I need to multiply this. So on the top, I'm just going to be distributing this radical 3 inside. So radical 3 times 5 is 5 radical 3. Radical 3 times 2 radical 3 is plus 2 times radical 3 times radical 3, which is radical 9. over, on the bottom, I'm only going to do my first and my last terms. So 5 times 5 is 25, because we know when we use the conjugate that our middle term is going to cancel out. And then do negative 2 radical 3 times 2 radical 3. So that's be negative. And then 2 times 2 is 4. And radical 3 times radical 3 is radical 9. Now, I need to simplify my radical here. Radical 9 is just a 3. So I have 5 radical 3 plus 6 over 25 minus 4 times 3 is 12. I'm going to move down here. And I can't do anything with what's in the numerator, but just because we're funny in math and there's sometimes we just like things to be in a certain order, we like to put the radicals second in our answer and our whole numbers in the front. And 25 minus 12 is 13. So I have now gotten rid of my radical in the denominator. I've actually, believe it or not, divided that problem. So this here is my final answer. And it always helps to look over the summary at the end of the lesson and just kind of read about it, see if there's any questions. But that is it for today.